Hello. Hello. Um, yeah, it's kind of been a long time. I'm sorry. Again, like 3 months since like the last episode, I guess. Um, yeah, I mean, I've been traveling, I've been working, I've been studying, but now I felt like doing another episode of our compiler stream. Didn't really haven't really done anything over the past 3 months, like regarding the compiler, but today I want to do something again. And it's kind of like boring, I guess. Not really boring, but I kind of want to rethink the current language design. Because I think the language is kind of becoming too functional, right? Like in the last episode, we made functions expressions and like only expressions. So not like we did not introduce lambdas. So like just all functions are um, just lambdas basically. And I don't want that, right? I want kind of like a more C-like language, more closer to the machine, so that we can actually build a proper backend in the end, like code gen backend, because like ML or like functional languages are kind of hard to generate code for. So I just want to keep it closer to C. And I guess that's step one of what we're gonna do today. So we'll just go back to like defining these functions as items. So we'll just have a name again and not be treated as variables. Yeah, I guess that's the first step. And after that, I kind of want to refactor the way that we are resolving symbols. So right now, it's basically we are parsing the AST and then just walking the AST again and getting type information and symbol information. But what we could do instead is we could, in the parsing stage, we could already try to gather some information about variables and functions, because especially functions, as they are fully typed, right? So every parameter has a type, and their return type is also statically typed. So we have all the information that we need at parsing time, and do not need to walk the whole AST again just to gather function information. We will kind of have to do that for the variable type information, but that is fine. We can do that. And maybe we will even construct another AST, like the Rust compiler, for example, has another kind of closer or more low-level type of AST called the HIR. So it's like, I don't know, yeah, like it's higher intermediate representation. So there are no for loops and no while loops. I think everything is just a loop, and some stuff else. You can read it up in the compiler documentation, but it is like fully typed, or like not the HRI. Actually, there's also a THIR, so that's like typed higher intermediate representation. But I guess we do not need that much complexity as of right now. Yeah, I guess we will. I don't know if we want to construct a new AST, like just clone the AST and add type information, or just have like a type unresolved and then set the type for every AST node afterwards. I guess that is what we could do. Yeah, we'll see, I guess. Yes, so I guess let's start, right? Okay, so first of all, we have to kind of adapt the AST, because there will not be a function expression anymore, but there will be a function item. So I think that's in the AST folder somewhere. I haven't looked at this project in a while, so okay, yeah. So we have a function expression, right? We do not want that. We want a function item. Function declaration. I guess we can keep that, right? It is used here. Okay. Where did we declare item struct? Here, okay. So right now the only item is a statement. But what we want is we want a function. And function is just, we'll just have a function declaration, I guess. Does that make sense? I feel like we could just smooth that into like an inner struct. Or is that used somewhere else? It's kind of dumb to have that as a field, right? Just kind of as a wrapper type. No, we'll just leave it because it's like nicer for pattern matching because you do not have to destructure the whole type every time you pattern match on like a function. You just have to like declare one field in the match pattern, which is pretty neat. So we'll just leave it at that. Okay, item kind function. Well, now so our function is an item again, and we will make a remove it from the expression. So from here and from our expression kind, we'll look for function expression up, and we will probably also remove rec expression, right? Okay, what the hell happened there? Okay, so remove that. And sure, so we can remove the rec expression and function expression. And we could probably also go to our lexer and remove the remove the rec keyword. Rec. Where is it? There we go. Okay. Because we don't need that anymore as of right now. Okay. So next step is probably add a function to declare or to create a function item, because right now we can only create a function expression. So func item, and that will just be it will return an item now, and that will be return self.item from kind, and that would be item kind function declaration func keyword parameters return type body, reorder that, and we will probably also need the identifier. So just add that back in here, identifier, which will be a token. Identifier, we have to add that to a function declaration. That. Cool. Nice. So now we can create a function item. Next up, let's remove the methods to create a rec expression and a function expression. Okay, the function expression we already deleted because we migrated it to the function item. We can also just get rid of those. No, not everything. Just those two. Okay, so we can ignore that because that is just a test. Maybe we'll adapt the tests later. So now the next step will be to go into the parser. And can remove that. Okay, so because our function is now no longer an expression, we do not have to parse it in our primary expression parsing function, but at like the highest level possible. So when parsing an item, so search for parse item, And here we'll say return match self dot current dot kind, and we want to look for func. So when we encounter the func token, we want to parse a function declaration or item in that case. And otherwise, we have not encountered a function token kind. We want to parse a statement. So just like that. Boop. Let's create that function now. We'll need a mutable reference to self, and we will return a statement ID. What we do is we say let function decl is self parse function func. How do we do that here? Okay, I'll just copy that. Parse func item. Go back in here. Say that. Okay. Func item. And we will not return a statement ID here, actually, like item ID. Yep. Okay. Let identifier. Cool. Now we have it, right? Okay, so we're missing the identifier here. Now it should be all set. Is it? Expected item ID found item. A reference to item. What is a reference to item? Oh. Okay, I see. Yeah. I guess we'll need a reference to an item anyway, so we can just return that. Cool. Okay, now we can parse func item. Next step. What is happening here? Okay, this has to be an underscore. Up. Now we have adapted the parser. So let's just adapt our example and see if that already works. It will not, because we will have compilation errors, but we'll just adapt the example to kind of see what we want to achieve anyway. Okay, so this should be func mul, right? Up. This should be func add. I don't know if we want to support like function declarations inside of another function, because then we will need like nested functions, or like not nested functions, but like a function scope inside of a function scope, right? Or a scope of function inside of a function scope. That will complicate things though, because then we will need to have we will have to think about like capturing. Because for example, if I have something like that, no, not that, like that, a is 10, and inside of here we then say like a plus a is like a plus 1, right? Let's just ignore the parameter here and referencing the same. And then this value has to be captured, right, and synchronized. And that is actually pretty complicated for compiled languages. And like not even Rust does that. I mean, it does, but like not with function declarations, but with lambdas. And they even have like the different kind of function FN traits that like specify like how you can capture variables. Like that's basically the difference between those different traits. Like I mean, the FN mute and FN once trait. Yeah. So I think for now it's best we don't do that, because it's basically like really complicated. Okay, you have to believe me that. Okay, but what we can do is let's just call this add, no, multiplication. Okay, maybe let's do that because it's a little bit more complex. Okay, so with sum, right? Okay, so what we want to do is we want to add b to sum. Okay, up, just like that. That should work. And we say c is okay. Like everything, like that should all stay the same, right? Yeah, it should. Cool. Now let's try to run this. It will probably not work, which is fine. So let's just resolve the errors here. Up, up, up. Okay. So we probably have to adapt our AC visitor, because right now we still have a wizard func exp and probably also the rec expression. So we have to change that func decal, or we just say self visit func decal, I guess. Something like that. Yeah. And then we'll just say func no, func decal. Right. Okay. So we can remove that. Oh. Up. Remove those two. Also this one. And now we will have to adapt all the different structures that implement the AC visitor trait, which is gonna be the evaluator. I guess we could do. Could we do that one first? I mean, yeah, we can, because basically we'll just do nothing, right? Because like, what happens when we visit a function declaration? What does that mean? That means that while evaluating some expression, we encounter this function declaration. Like that does not have a value, right? It doesn't return any value, so that just should never ever happen. So what we can do actually is just panic here, just for good practice, right? So that we will notice that something has not gone right here. Yeah, cannot evaluate function declaration, which makes sense. Oh, nice one. So basically, I've finished the migration of evaluator now, which was actually pretty simple. The audio of input members are differs from the trait. We can fix that. I love those quick fixes. I don't know, they're somewhat satisfying. Collapse nested if block. I guess we can do that. Why not? Visit error. You can also say like panic here. Cannot evaluate error expressions. Makes sense. So what else do we have to fix? Render. That makes sense, right? Visit func expression. Should be visit func decal. And that will take a function declaration, rename that. Help. We can rename that to func decal. And this will be item ID. Rename that item ID. Okay, so we can remove that. Just reference this by func decal to replace every occurrence. Parameters, and everything is basically the same. But not everything, because we now have an identifier again, so we have to print the name as well. So that will be self add identifier. Do we have something like that? Add type, add new line, add white space, add pure text. That's probably gonna be text. Yeah. And we'll need to add white space after that. Okay, one more error here. Yeah, we can just remove that. Now we have fixed the printer. Next up is our resolver. Okay, so this is where it kind of gets tricky, right? Because now we get into assembler resolving. I guess we'll just need to add back like function scopes and stuff. We can do that. Wait, let's see how we'll go about that. This will be func decal and function declaration. So it'll be item ID, item ID. Okay, I can remove that because now we don't have to set the type anymore because it's not an expression. Can rename that to func decal. And now we can remove it. Okay, that didn't work. Okay, we don't want to do that. Up. Func decal. Up, up, up. Okay. What do we actually want to do here? So like when resolving, we do resolve the function scope, right? Okay, so we will refactor that later, but for now we're gonna take the easy way, which is to just declare the symbol in this function, right? Like the consequences of that are that we will not have, or we only have like, no, we will not have forward references, right? So what we will not be able to do as of now is reference mool like here. We cannot say these mool A and B. That will not be possible. That will be possible after the refactor. Yeah. So where were we? Printer, evaluator, we have fixed that one. Visitor, we have fixed that one. Right. Compilation unit. Okay. Sure. So we create a functional global scope, so we still have a function scope. We have to adapt that though, because our function will need a name. Name string. Yeah, we will call it name. We could also call it like identifier, but I think like name is more clear, right? Yeah. Create function. So this will then also take the name. Fire string. Yep. Okay. Identifier, span, literal, backclone. Okay, so we just clone the literal out of the identifier span because that is the name of the function. So that refers to this token. Okay. I guess we can work with that. Okay, that we can just delete. Nice one, okay. We will not have a function type anymore. So we can remove that. That will induct some other refactorings, like this one. That function is just gonna be... Oh, we have to adapt the call expression. The callee will now be a token, right? Because we can only call functions as of now, which makes things a little easier, right? Like before, it was an expression, so we could basically like try to call any expression, and it would parse that. But now we only want to be able to parse like an identifier, or call an identifier. So we cannot have something like C and then call, because that makes no sense when our functions are not expressions. That will probably be possible in the future when we have like lambdas. For example, like lambda is something like that, and then we can say like lambda, but for now we will not do that. So our function, this will be identifier token, I mean. Yep. So what we can say here is just that our function is just gonna be a lookup in the scope with the name. So we just say self scopes global scope lookup function, and we will pass a reference to the identifier to the name, like the identifier that was called, right? Okay. I can just say that is our function, because it's gonna be an optional anyways. Like that. Now we can implement this method in our global scope. Just say fn lookup function, take a shared reference and take string slice for the identifier. Okay. Option function index, yeah, that's fine. We do not need to go in reverse order there, because we do not have different scopes, right? And we cannot declare functions twice anyway. Okay, right now that's actually a good point, right? Because at the moment we can declare functions twice, and the first declaration will then just be used. So that is something that we should keep in mind, I guess. Just writing to do here. Check if the function already exists. GitHub Copilot knows better than me. Nice. Okay. So we will just do lookup by name. I don't know why that does not work. What is the product? It just gives you the item, right? Those functions. Index back. Okay, so that is just the function, right? Yeah. Alright. Cool. That should work. So should we do a map and return the index, or should we return reference to the function? Not sure. Guess index would be cleaner, right? Because we also did that for the global variables. Yeah, I guess. Let's do that. Does that? No, that does not even work. So we have to like say iter. What was that called again? Like the iteration with the index iter. Okay. Makes sense, I guess. Index iter find. Okay. So bubble up. And so the index, we can ignore that. Okay, cool. Now we can look up a function. And we match on it to get the type. Yeah, makes sense. We like now if we have like no function, we don't want to report that we cannot call a non-callable expression, but we want to report that the function with the name does not exist. Okay, do we still have that error message? Port function already declared? No. Undeclared variable? No. Let's just see. Fn report undeclared function. Undeclared function. Yeah. Okay. Can do that. Let's go back to the compilation unit and let's just say report undeclared function instead. The token will be. What will the token be? The token will be call expression and call e. Yeah, because we want to report the part of like the expression that actually references the token, the identifier, which will be that one. So that should be underlined with the red squigglies. Guess that's fine. So this will not be type void valid. Well, I guess we could also make it type error because it actually kind of is an error. Let's do that. Okay, so we say functions get. Yeah, that's valid. That is valid. We clone the return type. Blah blah. Okay, makes sense. What do we do here? Look up function main. Yeah. Alright, now that is fixed. Can we run it? No, we can't. Where's, okay, now we have to fix stuff in our evaluator. So the function index, global scope, function, okay, wait a second. We have to make a lookup function when public. Okay, we can go back to the evaluator and say global scope functions. And now lookup function by call expression call e span literal blah blah blah, and we can say function map self global scope functions get f expect. Yeah, that's fine. We could probably extract this one into its own variable. Just say function name, like so. Yeah, that is valid. Please run. It doesn't. Okay. Why? It makes sense. Now instead of visiting like the call e expression, we just have to print the identifier. So that will be add text. I guess we could also, if we could practice, add a field to our call expression, like this, and say pop a name, like function name. Yeah, exactly like that. So now we don't have to type this out every time we want to reference the name. We can actually refactor some stuff with that. So we can do this call expression function name. We don't need to take the reference to that anymore. And where else do we use that? I don't even remember. Okay, doesn't matter. It's fine. Please run now. It still does not run. Okay, that makes sense because we have to adapt the AST and the parser probably as well. Where is this use? Here. Okay. Parse call expression. Blah blah blah. Identifier. Okay. I guess we can also remove that match block here. Can we? Yeah, we can. Okay. So why can't we remove that block here? That is because we cannot call expressions anymore, and we can also not call expressions recursively. So like in a language where a function could be assigned to a variable, you could probably do something like this, right? So because a could be a function that returns another function that you can then call, but like if a could just be a function like that, it cannot return another function, right? So this will never be possible. So we can just remove it's like kind of recursive parsing of the call expression. What we can do instead is we can say if we have an identifier, we now need to do a look ahead, right? So we can say if self peak, I guess. Yeah, we do have peak. Peak 1 are kind. If that matches token kind left parent, then we will return self parse call expression with the token. No, we have to match on the token, not peek ahead. Yes, we do. We have to peek one ahead, right? Okay. So why do we do that? Like imagine this. We have parsed the identifier, and now we have to decide, is that gonna be a reference to a variable, or will that be a reference to a function? It will be a reference to a function if the next token is like an open parenthesis, right? Because like in which other scenario will that be the case? It won't, because variables cannot be called, or like variables can hold reference to functions right now. So every time a function or like an identifier is followed by an open parenthesis, we will just interpret that as a function call. So now getting back to our parser, that's basically it. Like we just do a look ahead of 1. We say if the next token is a left parent, we just interpret the identifier as a call expression, or like as a function that is called. Yeah. Next error. Okay, now this is just for getting the text span. Okay. I guess this will just be the span of the call e. Something like that. Is that correct? Okay, it is. Cool. Oh. What? Okay. For a second I thought it will run. It actually doesn't. Which is kind of weird. Okay, I cannot link my program because I have not agreed to Xcode license agreements. That is actually funny. Okay, let me do that really quick. Type agree, blah blah blah. Cool. I've just agreed. Let's see if it works now. It actually is compiling, it seems like. Okay. What are you complaining about? What the hell? Okay, expected closing parenthesis found comma. Okay, so that seems to be an issue with our parser. Okay. Token consumed here, and like it seems that we just like consume one token too far ahead. So when we get here, we expect closing parenthesis. Wait. Okay. While self-current, like while the current token is not a right parent and it's not, we're not at the end, we parse an expression. And if the current token is not a right parent, we expect a comma. The current token is not a right parent. Wait, if the current token is not a right parent, we expect a comma, which makes sense. Okay, so we have consumed this token, right? Wait. Can't you see my whole screen? Okay, you actually can't. Wait. It's kind of dumb, right? Okay, wait. Let's do it here. You can actually see my terminal. Cool. Probably, let's see if I can fix that now. Probably can though, right? Can probably change my streaming settings while being live. Yeah. Okay, I mean, can I do something like that? Boop, boop. Okay, that did not work. Okay, it doesn't matter. I mean, you can see the code, right? We'll probably fix that in the next stream, though. Okay, so basically, like, we consume this token right here, because the token, of course, the token that we have consumed here is then being matched on. And if it is an identifier, like it is here, we go into this block. Oh, okay. That makes sense. Because now we do not have to look ahead, because we already are at this token, right? So that's the issue here. Because now if we peek one ahead, we take a look at this token, which is an identifier and not a left parent. So we do not parse the call expression here, but the variable expression instead. So we just take a look at the current token again. Yeah, like that. Okay. Now let's see if things run. They do, but we panic. Okay, it kind of bothers me actually that you can't see the terminal. Like, I can't fix that right now, can I? I mean, can I change the terminal position though? I think you can do that. Let's see. Terminal. No. What is it called? Position. Layout. Okay. I mean, I can make it bigger though. Okay, so we panic because we cannot evaluate a function declaration. That is actually why I put that panic here in the first place. So when we see that, now I wonder why we even like encounter this one. Oh, I guess I see why. Because in our evaluator, what we do is we basically like we enter at the item level, right? Where you actually used here? Okay, so you see that so we call the visit method on our AST, and our AST implements the AST visitor trait. No, it doesn't. Like it has a method to visit, to accept any visitor. And what we do here is we just loop over all the items and just visit them. And why do we clone here anyways? Do we have to? Yeah, we do. Why? That seems dumb. I guess doesn't really matter. Okay. Right. And that is why we visit that method anyway. So we do not have to panic here. We can just ignore it, basically. So now it should run. And it actually does. And you can see, can you see the result? No, you can't. Okay, so it basically says sum number 840. So the result is 840. And I'm not sure if that is correct. Let's see if that is what's supposed to be. So we say A is 10 and B is 40. We'll multiply 10 by 40, which should be 400, right? And let me say C plus D, and A should be like 10. So it probably should be like 410 though. And not 840. Okay. Interesting. Very, very interesting. Let's see the value of B though. Like B should be 40. It is. Okay, I can tell you that. Can't see. But this is what it prints. So it's 40. As print A should be 10. Yeah, okay, it is. Maybe there's just something wrong here. Okay, we say sum is 0, while B is greater than 0. We say sum is equal to sum is B. Okay, I think that makes no sense, right? It should be A here. Yeah, now we get this result. 420. Let's go. Yeah, and that seems correct. Cool, now we have successfully migrated our functions from expressions back to items again. So we basically have just reverted what we did in the last stream. Yeah, I mean, sometimes it'd be like that, right? It'd be like that. Yeah. Let me just take a quick moment, like 2 or 3 minutes, and see if I can fix the stream, because that is actually kind of annoying. Like that you can't see everything. But I guess it's gonna be kind of hard to change that while I stream. At least I suppose so. Yeah, I can't change the resolution. I don't know what happens when I can drag some things around here, like I don't know what happens then. Oh. Okay. It just gets smaller, which could be good. That actually seems kind of reasonable. I don't know. Is that good? I guess it could be. Nice. Okay. That was easier than I thought. Cool. So now you can see everything. That's kind of a bonus, kind of an advantage. Now, let's see, what can we do next? So what I wanted to do is refactor our symbol resolving, and I'll now try to figure out why I wanted to do that and explain it to you in the progress. So, right now, our symbol resolving is done by, where are you? The resolver. Okay, it's that resolver. And the problem is that we do not support forward declarations for functions, because we basically resolve everything like a linear fashion. So imagine this: we want to declare, have a function mul, and we want to call it here. I'm gonna say that I don't know, z is mul a times a, mul a, so a times a. This will not work. Hopefully it won't. Yeah, it doesn't. And it says undeclared function mul, which makes sense, because what happens is we walk the AST in resolving, and we take a look at this item, this item, this item, this item, and then we see, oh, we need a function called mul. But we haven't not seen that yet. It's only after here that we now know that there's a function called mul. But that's too late, right? So what you typically do is, like, either you have a statically typed function declaration like we do and like Rust does, so you can basically declare the functions when you parse them. What else, like what languages like TypeScript probably do, I don't know exactly, but I think what they do is they have like 2 or 3 passes actually. So they first parse and create the AST, then they like kind of try to resolve everything like in 2 or 3 passes and just loop over everything and do that until they figure out like which functions are there and which types they return. So I guess for now we will just keep the like statically typed functions, and we will try to declare them at like parsing time, which is actually pretty cool. So what I mean by that is we basically just take this code and move it out of here, basically. Yes, that's what we do. And to do that, we kind of have to pass the global scope to the parser, right? So what I mean is, how do I explain that? I mean, let's just do it, right? So basically, this statement right here will just go into parse func item. So after we have, even after, like before, so we can do recursive calls. So before we parse the body, we say this, self global scope create function, right? So identifier, and now we have a problem because to create our function, we need to pass the body expression ID, but to parse the body expression, oh no, we actually don't need to. We can do that afterwards, my bad. Because we only check if the function exists in the resolving step, right? So it doesn't really matter if we have a recursive call. My bad. Okay. So we basically do something like this. Yep. Okay. And we even get a function index here. So we could basically also just put that into the function item, which will make things a little easier in the long run, I guess. Because like the benefit that we get when we put a function index into our function item is that every time we want to know like which function symbol belongs to function declaration, we can just use that index. And otherwise we have to do like weird lookups by name, and later we will have different files, and so we could have like colliding names. And so I think that's actually like the best way to do that. So in here we can just say index will be a function index. So that is how we can look up our function in our global scope. Yeah. Next step. What do we need? We need a global scope. Values after being moved. Okay. That makes sense. Okay, the parameters are variable in indices anyways. Okay, that could make things a little bit more complicated though. Because now to create a function symbol, we also need to create the variable symbols and like the parameters, which we can do. But I'm kind of thinking about how we will handle the scoping though. Because in our parser, we do not have any scopes yet. So I guess we could just leave that step out. I don't know. Let's see. Okay. So let's just do everything we can. For now, we can move the global scope into our parser. That will probably be a mutable reference now, right? Mute. Hello. Global scope. Global scope. Global scope. Right, okay. So this needs to be public. Identifier seems to be correct though, right? Yeah, expected variable indices and found functional parameter. So how do we do that? I guess can just kind of copy that one. Can we though? I guess we can now use our global scope to declare a variable. See, declare variable and also it's be public. Right, cool. This resolve from string thing function also needs to be public. Resolve type from string. Can just make it public for now. It's fine. Where were we? Or parser. So import self-diagnostics. Okay, so we also need diagnostics. We do have diagnostics though. Yeah, we do. Okay, so now we have variable indices. And now we need our function body ID. Why do we need that? Can we just not take it by ownership? Like we can, well, we dereference it anyways, so we can just take ownership of it right away. And our return type, we will also have to parse that. So return type will be return type map, so from string, unwrap, or type void. Because if there is no return type specified, it will be void, right? Okay. So parameters. Declared parameters. I don't know. Kind of a bad name, but fine for now. Now we have a function index, which we can pass in here, and we will need that here. Function index, function index, function index, index, function index. Too many indices. Cool. And next step. Now we have to go here. Not here. First of all, I want to import resolve. Where is that? Okay. First of all, I want to fix visit function of the function declaration. Now we do not need to create a function anymore. The function index is just in our declaration index. We do not need to do that anymore, and we also do not need to do that anymore. But no but that's actually fine. Okay. Now see if there are any errors. There are. Okay, so we have to pass our global scope to our parser now, which means we have to create it earlier. So yep. Okay. See any other errors? Use of move valued. Does that make sense? Yeah, to clone it here, I guess. We do. Can't move out of function parameters, which is behind a shared reference. Okay, that sucks. Yes, let's just do that and do that here. Board is immutable. Yeah. Okay, let's do the classic Rust. Just clone it. Yeah, that works. Okay. Are you using an explicit closure for cloning elements? Consider using a dedicated clone method. Sure, why not? Okay. Let's run it. And it worked. We still get 420. I mean, we don't know yet if it worked because, oh, we do, because it now resolved this, right? Let's just return Z here. It should be 100. Please be 100. It is. Okay, cool. Very, very cool. Now, quick break. I'll go to the bathroom real quick. Just a minute or so, and afterwards we will fix that we can declare functions like twice or even more. See ya. Okay, let's continue. So, what is the problem right now? The problem is that we can declare this function multiple times. So, we could say, like, I don't know, mool, and we could say a int, and this could just be a totally different function. I mean, we could also just not make it return anything. Like that. I mean, probably have to. I would just say return 1. And now let's see what that will be. Function move AB expects 1 arguments. Okay, that is a pretty bad diagnostic, to be honest. Expects 1 arguments. Okay. Wait, let's fix that. Expects one argument if expected equals 1. If expected 1 arguments else arguments. So that should fix that error, right? Yeah. Cool. Function. Okay, why is that happening? Callie span. Query expression. Oh, I see. Okay. So that should fix that. Yeah. Cool. you see, now it just takes the first declaration, which we actually like do not want. I mean, it's pretty easy to fix though, right? So when we say create function, we just say result. Other way around, like, all right, error is left. No, okay, my bad. Error is right. Whoop. Return, okay. If self lookup function by identifier as sum, we just return an error. And it's as easy as that. Created function index. Result. And then we match on that. We say match index result. Blah, blah, blah. And we say, okay. Created function index. Can create a function item. Can say like function index. And we will need to change that, right? Because we will need a function index anyway. So we can just say, and this will also be a function index, but this will just be the old one. If that's some function we can just return this and say existing function index. So now we can use that here. We can say created function index and already existing function index. So here we also need to report an error, right? So we say that goes back. Borrow mute report declared function already declared. Okay, it's already used the function index. No, we don't need that. All right. Oh. Yeah. Okay, now we should get a different error. Function move already declared. Very, very nice. Okay. So that is working. I guess we can now either continue refactoring. Maybe I don't know. What could we do? We could maybe refactor our type resolving. But I feel like it's actually pretty solid right now. I don't really know what to do next. Okay, I mean, it's something that we could do, which I wanted to do actually, is kind of start getting towards like more low-level stuff, I guess, more towards like code gen. And what I had in mind was to actually start with transpiling to C. So we just take our AST and rewrite it to C code, which is pretty simple. But I mean, it works. And then we compile the C code and we basically have our first backend. Even though it's kind of whack, to be honest, because we let like the C component to do all the work. But it's a first step, and in the next steps, we could probably just try to create our own CodeGen backend. I'm not sure if we want to do that or if we want to go with LLVM. I'll have to think about it. But like for the learning experience, I probably will try to build my own CodeGen backend. Yep. Okie dokie. Then I guess let's try to build our CodeGen backend. Yeah, could be fun. Wait, is it valid? I want before that. I want to try something. Is it valid C to does IntelliJ support C? Help. New C file. Does it give me any IntelliSense? No. Okay. Int main return 1. Can I say int test return 1? So does that work? Let's see. GCC source AST main C. Function definition is not allowed here, and it doesn't work. Okay, good to know. Good to know. Up. So why is that good to know? Because if C supported it, we could just put everything in a main function. All the function definition and stuff. We could just basically transpile this and put it into main function. But we can't, which is fine. Okay. So let's say we want to create a new Rust file in CodeGen, the module file. Okay. So I guess we just put everything in here from now. C transpiler. Result and indent maybe. Yeah, I guess. Okay, so now we'll just implement the AST visitor for our C transpiler. Cool. Let's just start by writing on a empty function body. So is there something like a string buffer in C and in Rust? Let me Google that. String buffer Rust. Okay, so specify just to a string, so we'll do that. Result. Transpile type. Okay. Okay, so we now say self right type, like deco return type. Okay, so we need the global scope to get our function, and without having to worry like about we do not want to be too close to the actual source code. We want to just have all the parse information, right? So we say the function is self global scope functions get func decal index. Okay, so now we have a function, and we can say use the return type of the function. Fn white space. Yep. Oh, okay. And parameter self global scope variable get parameter up. So now we should probably do something like this. This should work, right? Oh, it probably won't work. Because in C, function bodies will never be expressions, right? That means that we will always need the curly braces, which is fine, I guess. Kind of. Let's see. So what would that print now? If we just instantiated a C compiler, C transpiler. Let's see. Compilation unit run, and then we say C transpiler is equals C transpiler new compilation unit global scope for that, and then we just say fn transpile itself, and that will take ownership and then return resolve. Returns cell or like self visit. Well, I also need AST, right? So AST. So we'll say AST visit self. Does that work? And return self result. Okay, cool. Let transpile code is C transpiler transpile. Let's see. Function rules already declared. Okay, so we still have invalid code. Let's just remove that. And we also have to print that. So okay, so cool. That's how our transpile code looks so far. And it does look kind of good, right? Looks valid, like valid C to me. I guess. So you could just write that into a file. Out C unwrap right all. I guess that will work. C file, I don't know. That's immutable. Okay, how do you do process? Is that something like that? Compile with clang. Using Rust. Okay, command. It's command, right? Okay, cool. So now we compile and get an executable, I guess. Run the compile binary. Wow! Okay. So this will probably panic because, yeah. Library system not found. But wanting non-void function. No such file. Okay, that was interesting. Okay, let me Google that. Oh. Oh no. Okay. I think my macOS update kind of broke some things. Let's see if we can fix that. I think we can though. So I just have to export the library path from my shell config file. Because it was, I don't know, it doesn't work with a new version, I guess. Let's see. Okay, still doesn't work. Which is kind of weird, to be honest. We can just compile it ourselves. So we can just say clang out C O out. Okay, makes sense. Because we still need like a main function, right? And like in C program always needs a main function. So the first step would be to say how do I put this? Like, if we have a main function, we don't need to generate an extra main function, right? And if we don't have a main function, then we would need to generate a main function. For now, let's just assume we don't have a main function. So basically, what we would do is we would just generate a main function, put all statements in it, and then generate all functions. And we also have to kind of watch out for forward references, because C does not have them without header files, right? So let's see. I think we don't want to do that here. We'll copy that, and we will do that ourselves. So in AST items, clone them is fine. Okay. Self visit item, but we will not visit every item, right? We will for now only we'll only visit if it's a statement. Self visit statement. Okay. And afterwards, we'll say like help. What the hell is happening here? Okay. And like afterwards, you'll do a second run and say now we want to visit all the functions. Function deco. Self visit func deco. Actually, it will probably be the other way around though, right? Because in the first run, we want to generate all the functions, and afterwards we want to generate the main functions with all the statements in it. Yeah, I guess it makes more sense, right? So just say self result push int main, right? Then we will do all that, and then we will push the string in basically end the code generation. Okay, I guess this makes sense. Let's see what the output is though. Okay, so this is the output at C. Looks valid, kind of, not really, because main doesn't return anything. So we will have to fix that. Self push indent, I guess. Self result string return 0. Yeah, we don't want to return 0. And so push indent is actually a pretty useful function, I guess. That should be called right indent though. Push string, no, right indent. I think there's some kind of weird, like, string formatter that like can basically write any amount of characters from variable. I don't know what's it called. What is it called though? Yeah, I mean we can do that. That's fine. It works, hopefully. Self right indent. Right new line. Okay. Cool. So this should now be valid C. And it kind of is. And weep. And now it looks better. Cool. So now we just need to write some stuff. Write indent, write type. We do not need to do that though. What we can do is we can just say visit statement. Self do something like that. Okay, how does that look? Whoop, whoop. Okay. Oh god. Okay. Why does that look so ridiculous? Okay. That's actually funny. Okay. Okie dokie. This variable expression. Yep. It's a number expression. Number. Number, just string. Boolean expression. Okay, no, that's actually wrong. If that's also wrong. Because there is not actually a bool type, right? Is there? No, there isn't. There is no bool type in C. So we also have to adapt this. This is also gonna be just int. Lol. That's funny. I almost forgot about that. Panic. Boop, 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 boop. Yeah, that's fine. Okay. So now we have to transpile the unary operator. Okay, we need to mesh on the kind though. Why is it called kid? It should be kind though, right? I'll just use the operator. Is that bitwise and hot in C? I guess. Okay. Okay. There's a assignment expression. Assignments are expressions in C though, right? Yeah, I think they are. Aha. Okay, so we've got arrow. Cool. Okay, so we can do binary expression next. Okay, wait. How's the shortcut again? That you can like edit multiple lines. Yeah, okay. Cool. I remembered. Okay, which ones are we missing? Power. Okay. There is no power though, right? Panic. Power operator not supported. Makes sense. So what else do we have? Visit. Parenthesized expression. Visit. Block expression. Okay. This one is actually a bit trickier. I mean, like not the block expression itself, but the like if an expression is user R value, so right hand side, I think right side value or something like that, and that means that it's used on the right side of a statement, like in assignment, it's on the right side. Then we have to watch out here because imagine the following code. Let's see. Yeah, exactly something like this. I mean, it's not a block expression, but if, and it's even like if makes it even more complicated. Imagine we have this D and we want to assign to it. Like, we cannot just put that code like one-to-one into C, because in C if statements are statements and not expressions. So what we would have to do there is either something like let's take this example. So let's just, I don't know, let's copy this here. Okay, so we want to replicate this. So what we would have to do is we would have to say int d, and then we say I don't know, if a is equal to b, d is equal to 10, else d is equal to 20. And because of like the inner blocks here, that makes it even more complicated. So there's like three nested blocks. So essentially what we then have to do is we need to use some kind of temporary variable like this. And then like another, probably, and like maybe even another temporary variable, and then we would say like temp 3 is 10, temp 2 is 10 3, and temp 1 is 10 2, something like that. Like it will look really dumb. And like we also have to respect shadowing, right? So because in our language we can shadow variables, meaning that something like this will be valid if we just say d is 10 and c would not. So we're gonna think about how we do that. But let's not think about all the edge cases right now. Let's just think about like the little easier stuff. Okay. I guess when we visit a block expression, what we would have to do is like maybe we will need to keep track of like a left-hand value, like a variable, which we can then later assign to. So what we could do is, let's say, like, we could say like L value stack vac variable index, something like that. And then we could say like if let some assign to is L val self L value stack last. Yeah, exactly. And the problem is that could just be like indefinitely nested though. And so the problem I'm seeing right now is something like, I don't know, so just make this a little bit simple. So this is the simplest version, so that will work, right? So the approach that we would use here is that we just say, okay, just visit like the last expression here, right? So for example, this would then transpile to int d, and then probably if a is equal to b, and then we would say d is just equal to the last expression. Yeah. Now imagine this. Up. Now the last expression inside of this expression block would be block expression. So we would need to say something like this. This is once again not valid C. Right? So what we would then need to do is once again go one level deeper and just say okay, then just ignore this for now and evaluate this right side and then assign the value. So that would be 10 then. I mean, in a more complex scenario, for example, say like a is 10, and a is 10, b is 20, and then we say a equals b. That would mean that we would first need to evaluate this value. So we just say probably like a is 10 and b is 10, and then we say d is a plus b. So we would kind of need to differentiate between expressions that are valid right side values versus those that are not. I guess that could be kind of hard. I need to think about that. So we need some kind of recursion in here. Probably I'd probably not do it on like specific expression level. Let's say like visit expression, and then we'd say self do visit expression, and now we okay, so now we need to check the expression kind, and if the expression is a valid right hand side value in C, then everything is fine. We can just proceed, right? But if it is not, we will need to have to pull it up and then basically kind of replace the last expression inside of the right hand side value with an assignment to the current left hand side value, right? And we would need to have to do that. We don't need to do that recursively again. Okay, this is kind of complex, to be honest. So let's just leave out the recursive part for now. Let's just do it one level deep. So we just query the expression and we say, okay, let is valid our value is match How do we write that? Match expression kind. Expression. Wait, is expression kind now public? It is. I think you can do ors here, right? Yeah, you can. Okay. Okay, let's just do all of those. Oh, okay, so this already needs to be recursive. Because why does this need to be recursive? Pretty simple. Our binary expression itself contains expressions again. So to determine whether a binary expression is a valid R value or not, both left and right of the binary expression itself have to be valid R values. So there is the recursion. Is valid R value. Self expression. All right. Nope. Okay. Okay, that works. Cool. Exactly. Okay, so there we go. Should be it. So if it's not a valid R value, if that's kind of the problem though, right? Because like, what do we do with that information at this level though? Can we do anything with that? I mean, we probably can't really do anything. Okay. I feel like, okay, so one problem with this approach we do right now could be, imagine this, we have this and that, and now we have if statement again, like if a equals b, I don't know, true, doesn't really matter. Like what would happen with this approach? Like just replacing, just looking at the L value stack, and then just inserting it, like an assignment, a statement in that block, would be that what would happen here is that just basically D would not be assigned to A and B, but it would be assigned to 2. And that would just be popped off. So we would also need to remember the expression ID of the right-hand value side, right? So L value stack, L value stack, and the corresponding expression ID. So if assigned to R value ID, if R value if R value ID is equal to expression, then we will do that. So let's see if we even need to do that. I'll probably just delete that for now. So let's just try this with a block expression. Um, I want to loop over every statement but the last. How do I do that? Yeah, okay. cool. Let's just... Okay, so... What happens now? Okay, so that is definitely bad. Okay, I think we're just gonna leave it at that for today. I mean, it's kind of working. It's compiling, so I guess we can merge it. Yeah, let's just merge this. I guess. I mean, it's fine. You merge it. Let's just merge it and... I guess I'll merge it tomorrow. Yep. So, my stream, we did some things, refactored stuff, got back to function items, and tried first version of C transpiling, which miserably failed, but we'll get there next time. Hopefully. Cool. See ya. Bye.